Today we start new topic, that is unit vectors. It is a vector whose magnitude is unit and have direction same as that of the given vector. Representation. It is represented by cap. So if A is any vector and we have to find out its unit vector, then it will be represented by A cap, comma, not by arrow. We will not put any arrow on the vector, we will just put a cap. So mathematically a unit vector is a vector whose magnitude, whose value is unit, whose value is 1, and have the same direction as that of a given vector. So if we have to find out unit vector of a given vector A, if A is any vector quantity then its unit vector, that is A cap, is equivalent to A vector upon modulus of A, that is its magnitude. So we can write it as A vector upon A, where modulus of A, this vector represented by these two lines, is called modulus of a vector of a vector. Now what is this modulus? That is equivalent to magnitude of a vector. Now first of all, how we can calculate the modulus of a vector? So modulus of a vector is represented by vector A and these two lines covering it as a bracket. So this is called modulus of vector or magnitude of vector A. Now if A is any given vector, say A equal to 2i cap plus 3j cap plus 4k cap, where I, j and k are the unit vectors along x-axis, y-axis and z-axis. So if any vector A is represented by these values, then we have to find out modulus of A or magnitude of A vector. Then we will put it as A equal to under the root, we will just square the coordinates and add all of them. So 2 square plus 3 square plus 4 square. So this will become 4 plus 9 plus 16 under the root. So this becomes 29 under the root. So this is the modulus of A, or magnitude of A vector. So if we have to find out, therefore A cap, if we have to find out the unit vector, so general formula is A vector upon modulus of A. So we will put the values as 2i cap plus 3j cap plus 4k cap upon under the root 29. So by this method we can calculate the value of A cap. So if we take all the three coordinates, then along x-axis, y-axis and z-axis, so we represent this unit vector as I cap along x-axis, j cap along y-axis and k cap along z-axis. So if we have to represent an vector, we will represent them in terms of these unit vectors as in the above example. So take another example. Find the unit vector of given vector A equal to 3i minus 4j plus 7k. So we have to find out the unit vector of this given vector A, whose value is given as this. So we will use the same method. First of all, we will find out mod of A. Again we will use the same technique. We will square the coordinates and add them. So 3 square plus, here the coordinate is minus 4, so minus 4 square plus 7 square. So this becomes 9 plus 16 plus 49. So this becomes 74 under the root. So this is the value of mod of A, or simply A, and we have to find out unit vector. So it becomes A vector upon A, that is equivalent to 3i minus 4j plus 7k upon under the root 74. Now representation of a vector in terms of its coordinates. So if A is any vector quantity, then A can be written as Ax I cap plus Ay j cap plus Az k cap, where I cap comma j cap comma k cap are the unit vectors along x, y and z axis, and Ax comma Ay and Az are its coordinates. Next we will do multiplication of a vector by a number or a scalar. So if A is any vector quantity, and we multiply it by a scalar, say m is any scalar quantity or a number, then the product will become m times the vector quantity. So if we multiply a vector with m, it will become m into a vector. Take an example. If a vector is equivalent to 2i plus 4j minus 7k, and we multiply this vector by a vector with 5, then say it is a new vector, b vector is equivalent to 5 into 2i cap plus 4j cap minus 7k cap. So this will become 10i cap plus 20j cap minus 35k cap. Now position vectors. If A is any object lying at this point, and we have to find out its position or direction, so we will always take a reference of any origin point. Say we have taken this as origin point O, so a line joining O to A, is called the position vector of A with respect to the origin O. So we can represent it as, if this is x-axis and this is y-axis, so in double coordinate we can assume it as r vector equal to x I cap plus y j cap, and if we take three-dimensional system, then we will include another coordinate, that is of z-axis. So what is the position vector? Position vector of a quantity is the distance between the origin point and the particle or the object. So position vector is a vector joining the origin point to the position of the object at any given instant of a time. A vector joining a point and the origin point. This vector is called position vector. So it gives us two things. It gives a straight line distance between these two ends, and it gives the direction of the object with respect to the origin. Now another is displacement vector. Now if A is any object having r1 as its position vector with respect to the origin O, and it goes from A to B position in a given interval of time, then its final position is B. Now if we draw another straight line joining B point with respect to the origin, so the position vector of B with respect to the origin say it is represented by R2. So displacement vector is a vector which tells us about the displacement of the object from one point to another point in a given interval of time with respect to the origin. So we can write it as OA vector plus AB vector is equal to OB vector, or AB vector is equal to OB vector minus OA vector, if this is represented by R2 and this is represented by R1. So AB, that is the displacement vector, is equal to R2 vector minus R1 vector. Our next topic is addition of vectors. We have to add two vectors or more than two vectors. Case 1. If the given two vectors are parallel to each other and in the same direction, if the given two vectors are parallel to each other and they are in the same direction, say this is A vector and there is another vector B vector. Both these are vectors which are acting in the same direction and parallel to each other, and we have to add them. So their resultant is represented by R vector, that is equal to the addition of the given two vectors, simple addition of the given two vectors. So that is in the vector form, or in terms of magnitude we will not put any vector sign. So R is equal to A plus B. We can take an example. If this is an object lying somewhere and a force of 10 Newton and another force of 4 Newton is applied on the object of any mass m, then what is the net amount of the force acting on this object? So that is represented by R equal to 10 plus 4. This becomes 14 Newton. So R is the resultant, which is the sum of the given two vectors, since they are acting in the same direction and parallel to each other. Take second case, case 2. If the given two vectors are parallel to each other but in opposite directions, but they are acting in opposite directions. So if A is the first vector and B is another vector, both these vectors are parallel to each other, their resultant is given by A vector minus B vector. If A is greater than B, then we can write R vector equal to A vector minus B vector, and in terms of their magnitude R is equivalent to A minus B. Hence, the resultant of these two vectors, that is R vector, will act in the direction of the bigger vectors. So we have assumed if A modulus of A vector is greater than modulus of B vector, then we can write it as R vector equal to A minus B vector. So we can take an example. If this is an object, a force of 15 Newton is acting from left to right, another force of say 10 Newton is acting from right to left. So the resultant of these two forces acting on this object will be 15 minus 10, that is equivalent to 5 Newton. Hence, the object will displace from this initial position to another position due to the application of the resultant force of 5 Newton. Now the third case, if two vectors are inclined to each other at some angle, say this is A vector and this is B vector, they are acting on an object. Now we have to find out the resultant. So we will place this vector at the tip of the vector A such that if this is A vector, we will place it as B vector. So the line joining the tail of A vector to the tip of the B vector is its resultant. So R vector equal to A vector plus B vector. So the resultant R vector is equal to A vector plus B vector. That is a vector joining from the tail of A vector to the tip of B vector. Now, to add a given number of vectors, we have different methods. Number one is triangle's law of vector addition. Number two is the parallelogram's law. And number three, if there are more than two vectors, then we use polygon law. So we shall discuss one by one all these laws. Now, before we start triangle's law of vector addition, one thing should be noted. If there are two vectors, A vector and B vector, and we have to find out an angle between them, then we will just place this vector B with the tail of A vector like this, without changing the direction of A vector as well as B vector. We join the tail of B vector with the tail of A vector. So this angle shows the angle between vector A and vector B. If the two vectors, this is the first case, if the two vectors are such that Then again we will place with the same method. Then the shorter angle of the two, if this is an angle and this is another angle, the shorter of the two angle is taken as the angle between the given two vectors. Here also there are two angles. The shorter of the two is taken as the angle between the given two vectors. Now we shall start triangle's law of vector addition. If two vectors are represented in magnitude and direction by the two sides of a triangle taken in order, then their resultant is represented in magnitude and direction by the third side of triangle taken in opposite order. That means, say if A is one vector which represents the first side of the triangle, B is another vector which represents the second side of the triangle taken in order. That means if we start from the tail of A, we go to the tip of A and then goes from tail of B to the tip of B. This is called taken in order. So if these two vectors represent two sides of a triangle taken in order, then their addition, that means their resultant, is represented by the third side. This is the third side, closing side, third side of the triangle in opposite order. That means if we go from this end, tail of A, to tip of A, from tip of A to the tip of B, from tip of B to back to O point, then this is called taken in order. But in this case we have to take two sides in order and the third side in opposite order. That means we will not go from this end to this end, we will start the vector from this end towards this end. So I have shown this arrow sign to this side. So this resultant R vector is equal to A vector plus B vector. This is the third side of the triangle taken in opposite order. This is the triangle's law of vector addition. Hence, in vector form, resultant R vector is equivalent to A vector plus B vector. This is the journal form. Now, calculation of the magnitude of resultant. So if A vector, B vector, and this is the closing side, R vector, just draw a perpendicular from this point which meets this vector extending to point this. So we will give the name to these points. If this is point O, say this is point P, this is M, and this point is N, and this is the perpendicular. Now the angle between vector A and vector B, that can be represented by this angle theta. we have to calculate the magnitude of the resultant. In vector form, we know R vector is equivalent to A vector plus B vector. This is the vector form. Now first of all, we should be able to understand what do you mean by resultant. So resultant is a vector which represents the effect of the given number of vectors. Again, I will repeat. Resultant is a single vector or a single quantity which represents the effect of the given number of vectors on an object, applying on an object. So if A and B are the two vectors which applies at a single point, then the effect shown by both of them is represented by this single vector R, which gives the same effect as these two have given in the combined form. So if we take an example, say this is an object and we have applied a force of 10 Newton as well as 7 Newton on this object, due to which it displaces from this point to this point. Now if we remove these two forces and applies only a single force of the value of 17 Newton, then this object again moves from this point to this point. That means this single quantity has shown the effect of the two single forces which are applied earlier. So resultant is basically a single quantity that gives the effect of number of quantities which are acting on an object or on an point. So to find the resultant of the two given vectors A vector and B vector which are inclined with each other at certain angle theta, we have used triangle's law of vector addition, in which we have placed vector B at the tip of vector A. Now these two vectors show the two sides of a triangle taken in order. Then the closing side, that is the third side, gives the resultant of these two vectors taken in opposite order. So that means the direction of the resultant force or the direction of the resultant will be along this vector. Now to find out the magnitude of this resultant, we have just drawn a perpendicular from this point at this point joining the line coming from OP. Now in triangle OMN, we know according to Pythagoras theorem, base square plus perpendicular square is equivalent to hypotenuse square. So hypotenuse square ON square is equivalent to OM square plus MN square. This is equation number 1. So if we put the values R square, we will not put vector sign here, we are taking the magnitude of the quantities. So this is represented as R square is equivalent to OM. So OM is the sum of OP plus PM whole square plus MN square. Number 2. Now in triangle, this smaller triangle PMN, sine of the angle, sine theta, is equivalent to perpendicular upon hypotenuse, that is Mn upon Pn. Therefore Mn is equivalent to Pn. Pn is equivalent to B sin theta. Similarly, we can find out cos theta. Cos theta is equivalent to base Pm upon hypotenuse Pn. Pm upon Pn. And we have to find out the value of Pm. So therefore Pm is equivalent to Pn is equal to B. So B cos theta. In the combined form, so put this third equation in equation number 2. So put this equation number 3 in equation number 2. So ON is equivalent to R. So R square is equal to OP equal to A plus PM. PM is equivalent to B cos theta whole square plus Mn is equivalent to B sin theta whole square. So this becomes A square plus, we will open the bracket, B square cos square theta plus 2AB cos theta plus B square sin square theta. We will use these two quantities. We will take B square as common. So A square plus B square cos square theta plus sin square theta plus 2AB cos theta. But sin square theta plus cos square theta is equivalent to 1. We have studied in mathematics. So A square plus B square plus 2AB cos theta, that is equivalent to R square, or R equal to under the root A square plus B square plus 2AB cos of theta. So this is the resultant, this is the magnitude of the resultant which we have to find out. Hence the resultant R can be represented by A square plus B square plus 2AB cos of theta. Now to find out the direction of the resultant, say this angle is beta, so we will find out the value of the angle beta. For this, for direction of R in triangle OMN, tangent of beta, that is equivalent to perpendicular upon base. So Mn upon base OM, and OM is equivalent to OP plus PM. So we will put all the values. Mn, that is equivalent to B sin theta, which we have calculated earlier. OP equal to A plus PM equal to B cos theta. So this is tangent beta, or beta is equivalent to tangent inverse b sin theta upon a plus b cos of theta. So by using this method we can easily calculate that with how much angle this resultant will be inclined with the vector A or with the horizontal direction. Now take certain special cases. Number 1, if theta is equivalent to 0 degree, that means the angle between vector A and vector B is 0. They are like this, A vector and B vector. Therefore resultant R is equivalent to, we will just use the formula under the root A square plus B square plus 2AB cos of the angle between them, and the angle between them is 0 degree, cos 0, but the value of cos 0 is 1, so it becomes A square plus B square plus 2AB into 1, but this becomes A plus B whole square, or R is equivalent to A plus B, which we have calculated earlier in the case number 1, when the two vectors are acting in the same direction parallel to each other. The resultant is represented by R equal to A plus B. That is being proved by this method also. Now to find out the direction, we will just find out tangent beta. So the general formula is B sine of the angle is 0 degree, upon A plus B cos 0. Sine 0 is equivalent to 0. So 0 into B becomes 0, 0 upon A plus B. Cos 0 means 1. So therefore tangent beta equal to 0, or beta, that is the direction of the resultant, is again same as that of the given two vectors, since it makes an angle of 0 degree. Now case number 2, if the two vectors are parallel to each other but acting in opposite directions, A vector and B vector, the angle between them theta is equivalent to 180 degree. So we will use again the same formula, R equal to under the root A square plus B square plus 2AB cos of theta. Cos of 180 degree. This becomes cos 180 equal to minus 1. So this becomes A minus B whole square, or A minus B. So we have achieved the same result as earlier, when the two vectors which are acting parallel to each other but in opposite direction, their resultant is represented by R equal to A minus B. Now to find out the direction of resultant, we will use again the same formula, R equal to B sine 180 upon A plus B cos 180, but sine 180 equal to 0, since sine n pi equal to 0. So therefore R equal to 0. That means the resultant will make an angle of, resultant means tangent beta, that means beta is equivalent to 0 degree. That means the resultant will make an angle of 0 degree. Now in the third case, if theta equal to 90 degree, that means the two vectors are inclined perpendicular to each other. Then again the resultant is given by under the root a square plus b square plus 2ab cos 90, but cos 90 equal to 0. So therefore the resultant becomes a square plus b square under the root. So this becomes the general formula for finding out the resultant, the magnitude of the resultant. Now the direction of resultant is given by the general formula tangent beta is equivalent to b sin 90 upon a plus b cos 90. Sin 90 equal to 1, that means b into 1 upon a plus b into 0, that is equivalent to tangent beta equal to b upon a. The direction of resultant is given by tangent beta equal to b upon a. So these are the general cases which we consider when we find out certain vectors inclined with each other.